Number 5 on the 2015 exam, consider the function f of x is 1 over x squared minus kx, where k is a non-zero constant. The derivative of f is given by f prime as that guy. Okay, part A, let k equal 3 so that this is our f. Write an equation for the line tangent to the graph of f at the point whose x coordinate is 4. So we need equation of the tangent line. So first we need the slope of the tangent line. And what's slope of the tangent line? It's derivative. Okay, so I think we could have used that, but I just directly used this to find f prime. Okay, so I didn't do that first, but f prime is, I can write this as x squared minus 3x to the minus 1 power. So power rule first, and then chain rule. And then they tell us that we want the equation of the tangent line at x is equal to 4. So f prime of 4, if we do the math, is minus 5 over 16. We have a slope. We still need a point. The x-coordinate of the point is 4. What's the y-coordinate? Well, we're putting x equals 4 there. The y-coordinate is 1/4. That's what this first line is. So we have a slope. We have a point slope form for equation of the tangent line right here. Scoring guidelines didn't say you had to write it in slope intercept form, so this should be acceptable. Okay, don't bother trying to simplify this. All right. Part B, let k equal 4. F of x is this. Determine whether f has a relative min, max, or neither at x is equal to 2. Justify your answer. So it would have a relative min-max at x is equal to 2 if the first derivative changes sign at x is equal to 2. So it either goes positive to negative, which means there is a max there, or negative to positive, which means there's a min there. If it does not change sign, stays the same, is neither. Okay, so derivative, again, I just used the power rule and chain rule, set it equal to 0. So what are the critical points? I can rewrite this as here, by the way. Okay, so the critical points are x is 2, 0, and 4. So we do the first derivative test. Okay, so the important point is x is equal to 2. So I just found all the critical points. It's helpful to get your regions to test. Okay, so in this interval from 0 to 2, or intervals to test, you can plug in like x is equal to 1 into here. Is f prime positive or negative? It's positive. We plug in like x is 3 into f prime. Is f prime positive or negative? It's negative. So since f prime changed from positive to negative at x is equal to 2, f has a relative max at x is equal to 2. You have to say that it changed sign from positive to negative, which means it's a max. Okay, you can definitely look at the scoring guidelines in more details. You see what gets you to point. Actually, if it's 2015, it might be more vague, but the important points, at least for me, are especially this positive negative. So you have to say f prime goes from positive to negative, so that's why f has a relative max at x is equal to 2. Okay. Part C, find the value of k for which f has a critical point at x is minus 5. Okay, critical points are when the derivative is 0 or undefined. So let's find the derivative of this in a general sense. Okay, same thing as before, power rule, chain rule. Okay, which simplifies to that. And as I said, the critical point is when f prime is 0 or undefined. So let's try 0 first. Okay, so I said equal to 0. F prime, this guy, minus 5. That's what it's asking for. Is equal to 0. So if we multiply both sides by the bottom, it goes away, right? So on the right-hand side at least. So then 10 plus k is 0. K is negative 10. Right? That's the answer for that one. Part D, let k equal 6, so that f of x is this guy. Find a partial fraction decomposition for the function f, and then find integral of f of x dx. So this we probably want to factor on the bottom as x times x minus 6. So we can rewrite it as a over x plus b over x minus 6. Multiply both sides by the denominator right here. So we get 1 is equal to a times x minus 6 plus b times x. Plug in x is equal to 6 because this term will go away. So b times 6 is 1, so b is 1, 6. Plug in x is 0 because this term will go away, so we get a is minus 1, 6. So therefore, this is 1 point right here. F of x this is the partial fraction decomposition. That's what it asked for. This is the 1 point right here. Minus 1, 6 times 1 over x plus 1, 6 times 1 over x minus 6. That's 1 point. And then it asks us to integrate that. So I pulled the 1, 6 out as a constant, and then I changed the order over there. These are just logs. After we integrate or find the antiderivative, don't bother simplifying, box your answer right there. Okay, and that's it for this problem. Lots of derivatives, okay, for ABC. Gotta know your chain rule very well, and then we have to know what critical points do, and max min when those occur with respect to derivative slope of the tangent line, that's that concept there, and then this is partial fraction composition. It's pretty algorithmic there, not really a concept there. All right, hopefully this was helpful. Please give this video a like if it was, and hopefully I'll see you in another video as well. Bye.